Hey students, so in today's video, I'm going to be going over some of the concepts revolving around similarity in geometry. I'm going to be going through some of the stuff in your content tab that's specific to our curriculum, and I hope this will be helpful for you. So just as a quick reminder, when two polygons are congruent, that means they have the exact same size and shape. These two shapes, for example, here are the exact same size, and they also have the exact same angles. Similar polygons specifically means when they have the same shape but may not be the same size. So their angles are going to be congruent. They're going to be the same size angles, but their sides are going to be proportional to each other. So scrolling down a bit here, these two shapes, for example, have the exact same angles. They look like they have the exact same shape, but their sizes are all proportional to each other. And in this case, they are all 3 times bigger in this orange quadrilateral than the blue one, because if I multiply, for example, this side 3 times 3, that gives me 9. 2 times 3, that gives me 6. 5 times 3 gives me the 15, and so on. It's important to point out that the order in which they say that the two triangles or shapes are similar to each other matters a lot. So we have these two shapes, and they say they're similar to each other using this little squiggle symbol here. And it says that DOG is similar to CAT. So D to O to G is similar to CAT. CAT. And so it looks like these are rotated a little bit from being oriented correctly. If I were to rotate this orange triangle so it had the exact same sort of orientation as the blue one, I would spin it around like so that the side 6 that is supposed to be corresponding to the side 3 is kind of on the left side there. This bottom side is corresponding to each other, and then the longest side is also corresponding in the same orientation too. So it's really important that you pay attention to the order. So let's start with our first example. It says that these two triangles are similar to each other. How are the corresponding parts related? And I would encourage you to take a second to maybe even redraw the green one so that it's oriented in the same way as the yellow one. And these little arcs in each of the angles give us clues for how it should be oriented. So I'll start just by drawing a triangle that's bigger than the yellow one, and we're going to label it in the same way that the green one is, but it'll look similar to the yellow one if it's oriented in the right way. So taking a look, we have the first arc down here that's just with one single arc there, and that clearly is corresponding to the R. Next, I'll take a look at the double arc labeled with P. This one in the green one has a double arc too, so I'll label that top part with an F. And then the one without any arc is the last one, which is going to be K. And this can help you to label the sides too. So labeling RFK, we're going to have the side 16 rotated completely 180, then the side 10, and then the side 20. This is just, it's really helpful to kind of keep things organized and in your head. So it first asks, what is PS corresponding to? And clearly that's this right-hand side here, FK. PS goes with FK. So I'll scroll down a little bit here and grab FK. And then scrolling back up, GS, what is that corresponding to? Well, GS is the bottom side. It's going to correspond to RK. I guess we didn't really need to label the sides with the numbers because they're not asking us about the number values. But next we're going to label GP, and that's going to be the last one left. GP is this side 8, that's going to be RF. And there we have it. Okay, so for our second example, we have two more similar triangles, and it says, what is the similarity statement? And I'm going to encourage you to take a look at first how this order is and see if you can match that order with the other triangle. So triangle DEF is going to go from D to E to F like so. And let's focus mostly on how those sides are labeled. I have my smallest side labeled here, and then my second smallest side was labeled first. So it basically goes side 4 to side 3 in that order, D to E to F. And then in the other triangle, okay, what is my middle side and then my smallest side? Well, my middle side is 8. And when I say middle, I mean like it's not the largest, it's not the smallest, it's the middle length. And then my smallest side is side 6. And so to go in that order, it would have to go H to K to G. So we're going to write that in that order here, H, K, G, and check our answer. Good. So for our third example, it asks which pairs of figures are similar polygons. Select similar or not similar for each pair of figures. And so what you have to do to test for this is see what that scale factor is and see if that is constant across all of the sides. And it's important to keep in mind that each side must have the same scale factor, and you have to test it for all of them. So starting with the first one, I'm noticing the top side here is 9, and the one that would correspond to it is the 18. 9 times 2 is 18, and so I want to make sure I have that same scale factor for all the 4 other sides. Let's go ahead and check the 7. 7 times what gives me 14? Well, that works. 7 times 2 is 14. And these are reflections here, and that's why I have to kind of go with this perpendicular side on the right and match it up with the perpendicular one on the left. Let's look at the bottom one. We have 16, and that is supposed to correspond to 24. 16 times what number is 24? It's not 2. 16 times 2 is not 24. So that one actually does not work because 16 times 2 doesn't work. I'm noticing it's not working for the 10 either. 10 times 2 is not 16. So these two are not similar to each other. Let's look at the next example. Now you can pick any side you want to get started with. I'm just going to go ahead and start with the top. We have this side 16 here, and it corresponds to the 40 in the other rectangle. 16 times what number gives me 40? Well, you might have to do a calculator for this. 40 divided by 16 to see what that equals. And that is 2.5 actually. So the scale factor for the second rectangle is supposed to be 2.5, at least for the one that I checked first. And I need to make sure that it works for the other side as well. So these aren't necessarily reflections again, but we can see that side 10 should be corresponding to 22. What do I get when I divide 22 by 10? Well, 22 divided by 10, if you need a calculator, you can check that, but it's not 2.5, it's actually 2.2. And so since it's not the same scale factor that I would multiply 10 by to get to this side, those two are also not similar. So those ones are not similar. I'm going to go ahead and clear the screen and scroll down to do the rest of them. Okay, so the last ones, these ones actually, I'm noticing something really interesting here. We could do that check with the scale factors to see if that's going to work. But there's actually an interesting thing about the angles. Now remember, the angles of of similar triangles or similar shapes has to be the same size. And I see that these ones are 61 degrees on the bottom and these ones are 69. You can kind of tell by looking at them that they aren't really similar to each other. But don't always go by how it looks in the diagram. Sometimes they'll make it look a little bit different, but the angle measures definitely are not going to work here. So those ones are also not going to be similar to each other. Let's do the last one here. We're going to check and start with what number do I have to multiply 12 by to get to 18. And so we'll do some division here. And it's worth noting that I did look at the angles as well to see if those kind of matched up with the ones over here, and it looks like they do. So 18 divided by 12 is 1.5. So that's the scale factor I'm going to be checking from the triangle on the right to the one on the left. So we'll check the next side, 14 and 21. What do I get when I divide 21 by 14? Taking out a calculator, that's actually also 1.5. Okay, so that checks out. Let's do one more. The bottom side here, I don't need to do the 14 and 21 again on the other side of that trapezoid. 33 divided by 22, that's in a calculator also going to be 1.5. So all of them have the same scale factor, and we get that those ones are going to be similar to each other. And those were all correct. So we'll end with that problem for today, and come to live sessions if you need any help.